For those of us living on the Gulf Coast, we are no stranger to the many challenges that come with this place that we love, and we are probably thinking pretty acutely of the various threats that come to the way of life we know and are most familiar with. Those threats have gotten more apparent over the last few years with extreme weather events like severe hurricanes far beyond the norm of what we might expect, as well as ice events and severe winter storms that seem uncharacteristic. Across that is a known issue that many of us are familiar with all throughout the Gulf of sea level rise. And so today's show, we're thinking through the various challenges of life on the Gulf Coast, where those come from, and what can be done about it. And we're talking to a leading expert who's just put out a new book all about those various factors. I'm Weston Twardowski, the Associate Director of Rice's Center for Environmental Studies and Associate Director of Eco Studio and Rice's Sustainability Institute, and you're listening to Gulf Streams on KPFT Houston 90.1 FM, Galveston 89.5 FM, and Huntsville 89.7 FM, where we talk with leading experts and community leaders to better understand the environmental problems and potential solutions facing our community. A quick reminder that you can catch up on Gulf Streams anytime through our podcast, available on all major podcast platforms. If you enjoy the show, please like and subscribe to make sure you never miss an episode. Dr. John Anderson is a sedimentologist, a longtime professor at Rice University, now emeritus, who has just put out a new book called Gulf Coast Demise, Climate Change, Conservation, and Saving the American Sea. It is a deep dive into the science around the many issues facing the Gulf Coast and the various concerns around what it means to be a person living in this part of the planet in today's world, and some of the things that we should be thinking about around what we can do to make this area a little bit more secure for the future. So I am delighted to get to sit down and talk through this book with you. Dr. Anderson, welcome to the program.
Thank you for having me.
Just to start off, I'm going to start with the obvious question, which is the question. The title of this book is Gulf Coast Demise, with a question mark. So I'm trying to read that with a question mark in my tone. But I'm curious about. That's both a bleak title and maybe that question mark points to some tiny sliver of hope. So can you just talk us through a little bit? Why Gulf Coast Demise? How worried should we be when we pick this up?
Okay. Well, first of all, the original title was Gulf Coast Demise, no question mark, nothing. And so the editors at Texas A&M Press added the rest. And I wanted to convey that the situation is serious, very serious, and imminent. And so we had to compromise on the title. The idea of the book is to convey, as someone who has studied, was born and raised on the Gulf Coast. I literally grew up on Fort Morgan Peninsula in Alabama. My father was a party boat fisherman. And so I can look back and I occasionally go back there, and it's not at all anything like I knew as a kid. And so these changes are happening, and the main problem we're dealing with is the fact that sea level rise has accelerated. And in fact, we're still learning. There are still papers being published now saying that, well, the calculations were wrong. It's actually accelerating faster than we thought. There was a paper just this past week on that topic.
I saw that in Nature, yeah.
Right. And so, and as a geologist, my approach to this problem is to look at how the coast changed in the past when the rate of sea level rise was as fast as it is today. We have to go back, by the way, 7,500 years. But to a geologist, that's not going back that far in time.
That's like nothing, right? That's just a little further than topsoil at that point.
Exactly. And we do have, actually in Texas, and particularly in East Texas, we have it's one of the best places probably in the world for preservation of coastal deposits that are, say, 10,000 years and younger. Barrier islands, bays, and estuaries that were drowned as sea level rose. And I'll point out that sea level rose 120 meters. That's 400 feet in the last 20,000 years, 18,000 to be exact. So sea level rise is nothing new. And to geologists, that's pretty well a given. But the problem we're having now is that the rate of rise is accelerating to the point, particularly in the last 30 years, that is taking us back in time to, like I say, 7,500, 8,000 years ago when the rate was this fast. What we're able to learn by looking at these older deposits is that the coast was changing drastically and rapidly during that time period. There are old barrier islands out on the continental shelf offshore Texas that are drowned now. They're completely underwater, under 20 feet of water in some cases, that were just literally overstepped and drowned in place by rising sea level. So there are estuaries that, we can sample and study offshore, what used to be Galveston Bay, Sabine Lake, Matagorda Bay. Their predecessors are now offshore, and we can study how they responded to this rapid rate of rise.
Maybe that's a good place to start is what were some of those responses? What were some of the ways that if we are thinking about 7,500 years ago as a model for how we might understand what our current reality is, what do we see 7,500 years ago happening?
Well, the first thing we need to know is that our coast is made up of many different environments, bays, estuaries, wetlands, deltas, wave-dominated deltas, fluvial deltas. They don't respond to sea level rise in the same way. One of the most complex response is barrier islands.
Yeah.
And so, in fact, we're still trying to understand how barrier islands respond. Estuaries tend to be one of the, not easier, but better environments to study because they record, or they accumulate sediments that record the response of an estuary to sea level rise. So many years ago, one of my students, Mark Thomas, and I, he did his dissertation in what used to be Galveston Bay during this time period of rapid sea level rise that's now offshore, but it has a really nice preservation of the deposits. So there's Old Bayhead Delta, estuary, tidal, all the things you find in the modern. And what we found was that at this time, the environments that occurred in that bay, in the ancestral Galveston Bay, stepped landward very rapidly. And so that doesn't mean, though, that this was sea level. And so in order to demonstrate that it was sea level, we looked at other estuaries from Mobile Bay all the way to Corpus Bay, and saw that the timing of these flooding events, we call them, when the bay was flooded and the environment stepped landward rapidly, was pretty consistent. We could use radiocarbon ages to measure these flooding events, and found that they occurred at about the same time. In fact, they coincided with times when we knew ice sheets had retreated rapidly. And so the mechanism was there, the response was there. And what we found was that, for example, Galveston Bay, what is now the Trinity Delta at the upper part of the bay, its ancestral Trinity Delta had stepped landward kilometers within centuries. So that's maybe not easy for most people to imagine, but if you imagine living on Galveston Bay and next to the Trinity River Delta up in Anahuac, and during your lifetime that delta shifts landward, out of sight, kilometers landward, that'd be a pretty remarkable rate of change. What we're finding today by actually mapping the current rate of change, because we can do that with satellites, of course, in other ways, is that the current rate of change of that delta is faster. It's retreating faster now than it was 7,500 years ago. And so, and that's not particularly surprising to us. I think we anticipated this because during the last 4,000 years, the rate of sea level rise slowed to a negligible rate.
Okay.
And what happened during that time is sediments sort of filled in the low spots, and we we call it aggradation. You built up the coastal plain to a relatively flat, featureless, flat, literally flat coastal plain, so that now when we get the same rate of rise we had 75 years ago, it is more impactful because you're flooding relatively flat topography. Now there are other reasons, but that's one of the main ones.
So that kind of leans directly into something that I wanted to talk about, which is, and you set this up so that you can really explore it and I think answer it in some detail in the book. But you mentioned one of the things that people frequently will ask you about is, how do we know this isn't just like a natural process? If the climate is changing, but the climate's always changed. So how do we know this is different in some way? And I think you've already alluded to, 7,500 years ago was the last time that we saw anything comparable to this. But I wonder if you want to talk a little more about the ways that we know this is significant and it is different than not only anything we've seen in our lifetime, but in many, many generations of lifetimes.
Right. I call that the Sarah Palin explanation of climate change. The climate has always changed, so what are we worried about? Well, there were times when the Earth was enveloped literally in ice, and so I don't think we want to go back to that. And there were times when it was extremely hot across the Earth and there was no ice. So there are these extremes in the past. And
our colleague Sylvia D likes to talk about the kind of ranges of temperature we're heading into. The last time it was this hot was when lizards and dinosaurs ruled the Earth.
Yes, exactly. And so, but I hear that a lot. I've given a lot of public talks, and oftentimes people say, "Well, how do you know that this is unprecedented? You've used the word unprecedented. How do you know that?" And again, that's the whole intent. Part of the intent of our research is to find out, is it unprecedented? Mm-hmm. And if it is, which, as I pointed out, we know it is, how's it different? In other words, compared to times in the past. Because, again, sea level is not the only thing influencing our coast.
Yeah.
Coastal topography has changed in the last 4,000 years. And so other things have changed, and we need to go back in time. There's no other way to do it. Unfortunately, we didn't have satellites in space 7,500 years ago. But we can do a pretty darn good job of mapping out these old coastal barrier islands, bays, estuaries. Get a pretty good sense of how they evolved over centuries. Well, it used to be thousands of years. We were constrained by radiocarbon dating when we started this work, 30 years, 40 years ago even. As time went along, our precision with radiocarbon dating got better and better. And so we went from saying, okay, well, this changed at this rate per century instead of thousands of years. Now we're at the point of being able to say the rate of change was this rate per decade.
Yeah.
So that's been a huge breakthrough for people that do my kind of studies, is just having better ways to constrain the timing. So we look at a place like Galveston Island, for example, and you look at an aerial Google image of Galveston Island, and you see these ridges that run along the island. They're called beach ridges, and they represent the old shoreline. So that at times in the past, we see that Galveston Island actually grew throughout most of its history. We can actually go in and sample, and we have those beach ridges, and say, okay, this is where the shoreline was 2,800 years ago, 1,800, 1,400, and actually look at the rate at which the barrier grew. Mm-hmm. Now those ridges are being eroded. Mm-hmm. And so we can, look at historical rates of erosion, compare that to rates of growth in the past. And we can do this with other systems as well. Bays are a little different approach, but in general, we are actually talking about real numbers that allow us to talk about rates of erosion or rates of growth, et cetera, and say, well, okay, climate has changed. The rate of sea level rise has changed. The response we can actually quantify.
See, it's interesting for me to hear you talk about Galveston in that way. It's something that I feel I grew up on the Gulf Coast as well. I grew up outside New Orleans. And I mean, it's something I've heard about South Louisiana for a long time. As you know, for
Hmm.
centuries, millennia, we were some of the newest ground on the planet, that we were an expanding, place. And then in the last century or so, due to a number of interventions, South Louisiana has just been dissolving essentially.
Yes,
And so, I mean, it's fascinating to hear about that kind of context across the Gulf, which I think is one of the strengths of this book, is you really do think across the Gulf. I mean, you were thinking from south tip of Texas all the way over to Miami, and really, where these places are experiencing different kinds of patterns. So, can you talk a little bit about which places along the Gulf Coast are the most at risk? Which are the areas that we're seeing most endangered by these rising sea levels, or other mitigating factors?
right. Well, as you mentioned, the Mississippi Delta, South Louisiana. There's a listeners may be interested in checking out NOAA's dashboard. It's called the NOAA dashboard, and it's an interactive online site, and you can go in and put in your hometown at Mobile, Alabama, and you can actually look at, say, well, what's it going to look like if sea level rises 8 feet or
There's a
eight
little
inches?
slider you can just
And a little
move up.
slider, and it shows how the shoreline is changing. It's an eye opener, believe me. And you don't have to push that slider more than about 30 years. By the time you hit 2050, the Mississippi Delta is gone. And much of the Chenier Plain, the wetlands to the west of the delta are gone. And so the rate at which this is happening again is very clear. And Louisiana, I always like to say that Louisiana is one of the most progressive states in terms of the use of science to understand their problem. The problem is they're in ICU, and they should have been worried about these things 50 years ago or 30 years ago. So now it's a little late. And in fact, they've attempted a couple of projects in the last few years to nourish the delta and try to regrow the delta, and they've abandoned those projects. Yeah. They raised the white flag. The other place that is, and I might add that, again, they actually did, however, to give credit to Louisiana, they do have one of the most progressive programs in terms of having scientific input to this problem. There are other states that shall go unnamed that are doing a terrible job of using science to understand this very complex problem. Mm. And there's no simple model. I mean, you open up a introductory textbook and it shows a house on the beach and sea level rises until the house floods. That's the simplest possible explanation of the effect of sea level. And so, like I say, different environments respond differently. The rate of sea level rise across the Gulf is different because of subsidence and other issues. One of the places that is particularly vulnerable for these is the Everglades. And again, for the last 30 years, there has been an effort to try to at least talk about and understand how to save the Everglades, because the sediment supply to the Everglades was diverted by changing drainage systems in Florida. And if these coastal environments, it's important for most coastal environments to maintain what we call vertical aggradation. That's a big word. But what it means is that you've got sea level rise, but if the rate of sediment accumulation is as fast or faster than sea level rise, nothing happens. It can even grow if it's fast. But that's rarely the case. Yeah. The Everglades is one of those places where sediment supply has been restricted, much like Louisiana, by diversion of the river and all the canals, levees that have been built. Everglades has a similar problem in that if you look at that map of 2050, the Everglades are gone. And these multi-billion-dollar studies that are being done and programs that are being proposed are, none of those are really going to do a lot of good. I'm afraid it's similar to Louisiana. We're going to have to come up with better programs. Another place that's near and dear to me, because I did part of my graduate work at Florida State, is the Big Bend of Florida. It's one of the most unique ecosystems in the Gulf Coast. And what really makes it unique is there are small rivers that drain into that area, but most of the water that's coming into that system is groundwater, and it's flowing through karst, underground limestone caverns. And it's really the hardest type of groundwater system to understand. And what we're finding is that the salinities are changing, and that is causing major ecological responses in what is, again, a very unique habitat. So these are three of our prized, ecosystems that are disappearing. At a smaller scale, these bays like Mobile Bay, the second largest delta in the Gulf Coast is Mobile Bay's Bay Head Delta. It's quite vast, and it's disappearing at an alarming rate. It was stable, based on our studies, for 4,000 years.
Yeah.
The shoreline of the bay where I-10 crosses Mobile Bay, you're at that kind of boundary between the bay and the delta. That is starting to move at an accelerating rate. And if you look at those NOAA maps for 2050, that delta is about 30 kilometers north of where it is today in just 30 years.
So two things. One, I mean, you mentioned the NOAA maps, and I think this gets at, a question that you also mentioned folks tend to ask you in the book, which is around, kind of hearing like, okay, well, an inch here, an inch there of, of sea level rise, how much does that really impact things? And I think I would certainly echo you, go look at the NOAA maps and kind of, put in a couple of inches and see what those effects are. But I think maybe that's a good place to ask, what are the actual levels of sea level rise we're expecting? And across the Gulf, I know that's different. And so can you talk us through that a little bit as well? Because I think for many people, they assume, the sea level just rises at a kind of stable, even rate and will impact everything equally. And that's not actually what we see. So can you explain why that's hitting differently and what some of those impacts mean if we are talking about 3 inches versus 5 inches versus feet, and how likely are those scenarios?
Absolutely. If you drew a line at Mobile, Alabama, east of there, the rate of subsidence is about,
and this is sinking land.
Land subsidence is about, it's significantly lower than it is to the west of Mobile Bay, and the highest rates are near the Mississippi Delta. Now, a lot of the subsidence occurs due to a lot of factors. Part of it's just we're on a big basin and it's subsiding.
Yeah.
But that Florida lies outside that basin. Texas and Louisiana are adjacent to the basin. So we have what's called tectonic subsidence that's higher here than in the east. The other big factor that people at LSU and Tulane have discovered is that sediment compaction is actually the biggest component of subsidence. So that if you go to Louisiana, you've got this rapid rate of accumulation of sediments for the last several thousand years as the Mississippi Delta was actually growing. And by the way, the Mississippi Delta has grown throughout its history. So what's happening now is a reversal from the history of that delta. If you look at the rate of subsidence there, it varies a lot depending on growth faults. But one of the big factors is the thickness of the sediments that were deposited in the last several thousand years, which varies significantly from a few feet to several tens of feet.
Wow.
And so when you start to look at the rate of compaction, which is pretty easy thing to calculate, the big difference is in the thickness of these soft water-saturated sediments as they start to dewater. But it's kind of a broad effect, and unfortunately for New Orleans, it sort of sits right in the middle.
Yeah.
If you come over into Texas, we also are on the basin, so we have relatively high tectonic subsidence, but the thickness of these younger, what we call Holocene, last 10,000 years sediments, varies from the middle of Galveston Bay, where it's over 100 feet of water-saturated mud. If you go outside Galveston Bay to a place like Freeport, it's a foot or two. That's a pretty big difference. And so that equates to a very different rate of subsidence due to the compaction of these sediments. And it occurs at an almost localized scale. The thickest sediments occur in these old bays, And so the rates of subsidence in Galveston, for example, is quite high. Turns out the longest tide gauge record we have for Texas is Pier 21 in Galveston. It's a very anomalous record because it's sitting right in this area of very rapid subsidence. If you look at records just a mile away outside the valley, the subsidence rate is significantly less. So that thickness of sediments varies a lot along the coast.
Yeah.
And one of the things we've been trying to do over the years is map the thickness of these sediments using seismics to understand. We've known for a long time the rate was highly variable, but how does that relate to, say, for example, sediment thickness? We know now it's pretty strong correlation.
Yeah. So, I mean, that's kind of fascinating, especially, being here in Houston. I remember a series of stories last year that a study had come out indicating Houston has, some of the fastest subsidence of any city in the country, which just, impacts different places differently. It's one of those interesting ones where a lot of things you can map in Houston and see, very distinct patterns, and subsidence is something that's not necessarily fitting all of the kind of human-based patterns that we're used to. And in some places is, where we see a lot of expansion and people are, using lots of groundwater or something, there's elevated rates. So it's one of the interesting areas that I've been seeing that I'm like, yeah, I can see how, especially over the course of the Gulf Coast, it would be really difficult to predict or know exactly where those issues are going to pop up.
Absolutely. And again, Texas is one of the most complex regions in terms of substance and variability in substance. We have significantly fewer tide gauge records, and so fortunately now we're measuring these rates from space, and this is very critical because we can now begin to and see this complexity and how it relates to the thickness of sediments, to growth faults. You mentioned groundwater. In the 70s and 60s, we were actually using groundwater for industrial purposes. And the area around Clear Lake, in fact, NASA subsided 5 feet.
Whoa.
Within a matter of 3 decades. And they said, whoa, we've got to stop this.
Yeah.
And so they did, and that stopped. I just read an article this week that the city of Corpus Christi is now struggling with a severe water issue. It's going to get worse as the climate gets drier, which models suggest it will. And one of the things they've suggested is that the industry there in Corpus rely on groundwater, and that frees up the reservoir for urban use. Well, we know from experience here that's not a good thing. So we're going to have to look for other ways. I have a feeling that's not going to get very far.
Well, I think what's really interesting about what you're also indicating is that these problems that we experience, these kind of environmental challenges that we face, aren't in isolation from one another. That, as the world gets hotter, we need, to find water in new places. Okay, so if we turn to groundwater, that contributes to subsidence, especially when you're talking about a coastal city where we have sea level rise. I mean, we can kind of understand city getting lower, sea rise going up. This is not a good combination. And so I'm curious about how these compounding issues are playing into this. And I think that's something that, not to lean too much into your original title, but I think that is one of the things. The Gulf Coast does seem uniquely at risk from a wide range of overlapping challenges. I think the most obvious of which you do allude to in the book, is hurricanes. But can you talk a little bit about some of these compounding issues? And that, goes for rising heat levels impacting hurricanes. But I mean, I know there are other things as well where we're seeing more extreme events, different kinds of extreme events, and just things that we might not immediately assume would actually be connected to each other, but are, triggers of kind of risk that multiply.
Sure. One of the things that severe climate events are something we're getting used to in Texas.
Yeah.
Severe freezing. When we had the freeze a few years ago, people would say, well, I thought it was all global warming. And what we're seeing is global cooling. And I point out, no, that's actually due to global warming because.
Can you say more about that? Because I think that is something that people really get confused by. I think it's something that folks are very. I think, it's one of those difficult things where, especially from a scientific perspective, it often takes years or decades to really come back and say we can attribute, X specific event directly to climate change. I know just this last year, Hurricane Katrina, some work came out that finally said, like, yes, actually we can measure that Hurricane Katrina was strengthened by climate change, and we can. I mean, that's been 20 years, so it's
Yes.
these things take a minute, but I do think that's something that folks really struggle with. So I'd love to hear you talk more about how the heating planet can drive extreme cold events as well.
Yes. One of the things I'm very disappointed in here in Houston is that our weathermen never use the terms climate change to try to. I think they could play a very important role in educating people on these things. And one thing they could do is point out how important the de-icing of the Arctic is in Houston's climate.
Okay, connect those dots for me, because I'll admit I'm over here like, what?
So we know from satellite data that the sea ice cover in the Arctic is getting smaller, significantly less. That results in the Arctic Ocean heating up. It's absorbing more sunlight, what we call the albedo effect, that water absorbs more of the sun's radiation than does ice. And so the net effect of this warming, though, is that it causes the Gulf Stream, the jet stream, to relax, to become more sinuous. And what happens is the jet stream gets more sinuous. So if you look at those weather maps that show when we're going to get an extreme cold event or when we're going to get an extreme hot event, more often than not, you'll see that they do when the weatherman shows the jet stream, there's a big dip in the jet stream that in the wintertime allows cold air to come down out of Canada and drop our temperatures, and in the summertime allows warm air to come down and raise our temperatures. So there's a direct correlation there, and any meteorologist understands that. There's no, to my knowledge, scientific debate about this. And this is something, again, this is why I'm kind of getting down on weathermen, that I'd like to see them use terms like polar vortex, these terms, or educate the public better about why our climate is changing. It's not just the heat. We show these graphs of temperature over the last 30 years, and people say, that doesn't look like a big change to me. Well, wait till that big freeze comes in the next 20, in a matter of 24 hours. That's a big change. And that's actually related to global warming. There's a direct correlation that's been spelled out. So in the southern hemisphere, similar things are happening. Well, it's very different, of course, the geography. But there are things happening there that are causing warmer ocean currents to move further south into Antarctica and melt ice shells from beneath. And scientists are very concerned that at the rate these ice shells are melting, they're going to collapse. They're holding back the ice. They're like dams. And that's going to cause a significant rise in sea level, very punctuated sea level rise event. So when we talk about acceleration, that's kind of that's kind of the part we can understand a little bit better. It's those punctuated events that would result from a significant or melting in Antarctica that we don't understand. We can't predict very well. I've been working also in Antarctica for many years, and I'm just amazed that I went there 50 years ago at our knowledge, how it's grown about the Antarctic weather and climate, and to understand how much that impacts us because of the vulnerability. The Gulf Coast is particularly vulnerable to what happens in West Antarctica. If you look at, because the meltwaters that are formed don't just get randomly distributed across the globe. And scientists know that the Gulf of Mexico is a hot spot.
Okay.
When West Antarctica starts to melt and accelerate sea level rise, we feel it more than the Atlantic coast. So it's very complicated, and scientists try to be cautious in how they convey this information because we don't want to confuse the public. But at the same time, to kind of get back to your question, things that are happening far away at the poles
Yeah.
are having a very dramatic effect on our climate and sea level rise. The last time, if we go back 100,000 years ago, sea level was 20 feet higher than it is today. So we know it can get a lot worse.
Yeah. Are those the kind of numbers we're thinking we might be facing? I mean, I think that's something that we do. I think, especially for listeners of this show, probably folks are more aware of this and probably a little bit on the kind of page of like, yeah, I know the ice is melting. I know the water's going up, but I don't know that we have any concept of how much that might be. Can you elaborate a little bit? I know even across the Gulf Coast, like as you're indicating, it'll impact different places differently. But what are the kind of levels, especially if we continue on the trajectory we're on for a moment, let's just keep it there and say, what are the kind of levels of sea level rise we might expect?
The numbers vary a lot, but if we look at 2100, take it out to the year 2100, we could easily be talking about 10, 15 feet, according to some estimates. The further out in time you get, the more unrealistic, or not unrealistic, but difficult these predictions become.
Yeah.
The thing, let me just back up a minute
Please.
and say, well, what's causing the rise? And the cause of the rise is the oceans are heating. We know that. We've been measuring ocean temperatures for 100 years. There's no scientific debate about this. The oceans are getting warmer. The Gulf of Mexico is getting warmer than the average. And so as the temperatures get warmer, ocean waters expand, and that's causing about 1/3 of the sea level rise we're observing. The other 2/3 is coming from melting of glaciers and ice sheets. Of the 200,000 or so glaciers in the world, about 90%, close to 90%, are in retreat. And many have disappeared in the last century. And so when you look at those, and now we can measure that retreat from space so much better.
Yeah.
So our knowledge is just increasing exponentially with each new satellite that's, sent up. And so we now know that rate has increased, the rate from land glaciers.
Yeah.
Antarctica is the biggest potential, and Greenland, the two existing ice sheets. They have enough ice to raise sea level again 400 feet if they were entirely melted. That's not going to happen in 100,000 years. Well, in 1,000 years. It could happen in 100,000 years. But that is, that is not well constrained. It's the biggest component.
Yeah.
Greenland can be pretty well constrained because we can measure how the ice sheet is shrinking because it has shrunk back to the point now where it's all on land. So we can measure the edge of the ice sheet, the height of the ice sheet, and know from year to year how much ice is being lost, calculate how much that contributes to sea level. And that's the biggest component right now. One of the reasons it may be the biggest component is because we don't know that rate for Antarctica because that ice sheet extends out into the sea. It melts in the ocean. Some of that melt is icebergs that break off and drift north. Others ice flowing out from under the ice sheet. We have very little knowledge of what that contribution is.
Yeah.
It could easily be larger than Greenland. So,
Wow.
yeah. So it's really difficult to sort of quantify what that contribution is now, let alone what it will be in 30 years or by the year 2100.
Yeah.
There are very realistic models that suggest that the West Antarctic ice sheet could collapse within a matter of a century or so. Very respected scientists have published papers on this. And so it's a very disconcerting lack of knowledge. And I realize I dodged one of your questions. I didn't answer your hurricane question. As the Gulf of Mexico has gotten warmer, you mentioned, Harvey, and as the Gulf gets warmer, of course, when you heat the water, you energize the hurricanes. You add that's where they get their energies, the heat from
Yeah.
the Gulf. But they also increase in terms of their moisture content significantly. So about a 1 degree rise in Celsius in Gulf temperatures can result in 10-20% easily increase in the amount of moisture in a particular hurricane, even as much as 30% I've seen. So we're getting wetter storms, and we're getting storms that are intensifying right before they make landfall. And so they're less predictable in terms of their impact because of these reasons. And so climate change is a big factor in hurricanes, and that's been long known. It's been talked about for many years, but we're starting to understand it better.
It seems like, I mean, for many of these things, is what I've been thinking about kind of throughout this conversation, and maybe starting a little bit with that introduction where you mentioned growing up on the Gulf Coast. I think it's fair to say I'm a bit younger than you are.
Yes, I'm sure.
only going off of the emeritus status here. But I mean, in my lifetime, I have seen real things that feel like changes, and in the 30-something years. And I think when I talk to folks who have lived on the coast their whole lives, when I talk to folks who are in their 70s or 80s, I mean, just the degree of change that folks talk about, what my father or my grandfather described when I was growing up versus what I've seen in my lifetime. And, it used to be these kind of feelings of generational change where it was like, okay, so 100 years ago, it was, something different. And I mean, my friends and I in our 30s will sit around and we'll sit here and we're like, no, we remember when they put that cemetery in 20 years ago because that was the high ground, and now it's underwater.
Right.
And I mean, in places, especially in Southeast Louisiana, I mean, you can just map it out and walk in certain parts way down south where you're going around and you're like, why are telephone poles underwater? Right? They weren't built underwater.
They weren't built there.
And they weren't built all that long ago. And so I mean, I think that kind of visible shift is very real in some places. But where it's not as visible, I think, especially places like here in Texas, yeah, we do feel these increasing storms. We do feel, the flexibility of why are we having more freezes? Why are we having more extreme ice events? As you indicated already, I don't think that folks know that's related to the jet stream, but we do understand something feels different. And even at the interesting level, I mean, you mentioned you wish weathermen would talk more about these things. I feel like there's often, maybe more on the meteorological side, a little bit of a hard line of weather and climate aren't the same thing. But of course they're interrelated.
Right. Yeah, I actually used to tell students 10, 20 years ago, I do climate, I don't do weather.
Exactly.
Now I say, I do both. and because the rate of climate change has increased now to the point where it's influencing weather.
Exactly.
And this is why weathermen need to be talking about it. They're not, we know, you won't find many climate scientists today who will say, well, we don't talk about weather and climate in the same breath, because I think most of us now are climate scientists are coming around to thinking they're very closely related. And these systems that we're describing every night on the Weather Channel are actually being influenced by things that are happening 1,000 more miles away, thousands of miles away. And so, yeah, they are related.
And we feel it. I mean, we feel it in these events. We also just feel it in, our annual summers getting hotter. And so I think those are things that
yes,
I think there was a series of kind of think pieces a couple of years ago, especially around the mini fires that occurred. But it does feel like there's been some kind of shift where people across the country, frankly, are experiencing climate change in ways that feel very tangible, very lived in, and that it brings it home in a different way where we understand something is different and we don't quite know what that means.
I see the word paradigm used in almost every publication now. Nobody used the word paradigm 20 years ago. Now everything's a paradigm shift.
Yep.
I'll give you my personal experience on this one. As I mentioned, when I was a young guy, in my teens, up until I was in my early teens, I lived on the Gulf Coast in Alabama. My father was a party boat fisherman, and I would go back there, and it's nothing like it was then. When my parents retired, they bought a house on Dauphin Island, Alabama,
Yeah.
and which is where their house was, which is on the bay side, by the way, is now gone. Frederick took it out, and it never came back. Hurricane Frederick. I followed, and I catch a lot of heat from my colleagues because I have a house in Galveston.
Yeah.
It's on the bay. It's on the highest elevation you can get, and it's built like a fortress. But when I built that house 25 years ago, my wife and I built the house. It's a smaller house, nothing to brag about. But 2 years ago, my neighbor and I raised my dock 8 inches. As a sea level person, I have a mark on my dock. I know what sea level's doing. I'm watching it probably closer than most of my neighbors. And so when it got to 8 inches, I raised my dock 8 inches.
Yeah.
And so that's a well-known, I mean, for me, I know what the rate of rise has been.
Yeah.
I know that I'll have to, if I were going to be here in 10 years from now, I would have to raise it probably another 8 inches based on NOAA's forecast.
Wow.
So, we've had very serious talks with my daughter and said, well, we'll probably not pass the house down to the family because, 30 years from now.
Do you actually want to have this? Yeah.
Yeah.
Okay. So this, not surprising given the title of the book, but Gulf Coast Demise here. There's a lot here that I think's been heavy and is kind of, I'm sure, weighing on listeners. I am curious if you can talk a little bit about what's being done to address this. Are there, places we should be looking to that are doing really successful mitigation work or that are leading and helping to protect the Gulf Coast? Or are there things that we should really be thinking about? What are steps we should be taking to try to brace ourselves for some of these changes we won't be able to stop and simultaneously maybe reduce some of the impacts of what is changing?
Chapter 9, the last chapter, focuses on that question. Well, what can be done? What should be done? And unfortunately, there are a lot of multi-billion-dollar projects that have been, most of which have, in fact, all have been funded, that are the Louisiana project we mentioned. Mm-hmm. That one's pretty well been abandoned.
Been scrapped, yeah.
The Everglades, not sure where that one's going to end up, but it's not looking good for the Everglades. And so here in Texas, we have what's called the Ike Dike. Being Texas, we can solve anything by building a wall. And so the problem is that for the suggestions for Texas, our problem is we're running out of sediment. We ran out of sediment a long time ago. And so, as we said, sea level rise and combating sea level rise is all about adding sediment to an environment, coastal environment, as fast as the rate of sea level rise. That's a lot of sediment. So if you're going to preserve a wetlands, you need to pump sediment in at some point to that wetlands to allow it to vertically aggrade. Again, that word, vertical aggradation. Unfortunately, Texas has not been as scientifically aggressive, and most states haven't, with the exception of Louisiana, in trying to quantify where there might be sediment resources, especially sand. It's the hardest to find, and in Texas at least, and how much is needed. So the Corps of Engineers has put forth a plan for preserving the coast by expanding the beach. They're talking about millions of square meters of sand that are going to be needed just to hold the beach where it is today, just to fortify the beach. They don't have a clue where that sand's going to come from. They talk about mining offshore banks like Sabine Bank. When you do the numbers, when you do the calculations, that's just not going to get it done. Now, there are sand resources offshore. Huge resources, millions of square meters of sand. And so my recommendation as the book is we need to quit, worrying about these little sand pockets that we can We can barely maintain the beach in Galveston, let alone the rest of the coast, Texas coast, which is eroding at 3 to 5 feet per year on average.
Wow.
And so those are big numbers, and people don't tend to be worried as much about San Jose Island or Matagorda Island, but they're eroding too, and that's impacting those barriers in terms of their capacity to help, combat storm damage, things of that nature, offset storm damage. So we need to be looking for a lot of sand. In my opinion, the state of Texas needs to buy themselves a hopper dredge, and they need to start dredging 365 days a year and distributing that sand. There is sand. They are starting to look out for it now. The General Land Office, they've done some seismic work. A lot of that is duplicated efforts that have already been made. We've done a lot of seismic work in the past. I'm not sure that's being used today, but there's a need to get down to specifics. There is a need for more scientific input. State agencies are trying to carry the ball. What the state of, and the exceptions of Louisiana, when Louisiana has a subsidence problem, they bring in the best people in the world, many of whom are in the Netherlands, to advise them on what the problem is and how to deal with it. We're not doing that in Texas. I don't think that, I'm pretty sure Alabama, Mississippi are not doing it. And so to answer your question, there needs to be more scientific oversight by the states and the state agencies that are the ones who are actually tasked with helping solve the problems.
Yeah.
They need help. It's clear they need help based on some of the strategies that they have recommended. The Corps of Engineers won't solve the problem. The General Land Office won't solve the problem without scientific input and oversight from people who are more knowledgeable. When I ask them questions, they're the first to say, well, that's not my expertise. Well, find the expertise and get them in here because we need help. Yeah. A surgeon who's doing a heart operation doesn't walk out and tell the family, sorry, we couldn't save your loved one, but we didn't have anybody here who was a cardiologist and understood it very well. So, and that's kind of the state we're in.
It sounds to me like one of the things you're getting at is there actually are initiatives that we could be taking. There are steps that could be taken to start addressing some of these concerns, to really at least mitigate some of these issues. And, in some cases, I think that's buying us time. In some places, it could really mean fundamentally reshaping what parts of the coast look like. But the kind of overarching idea here is that we need to be taking this very seriously and be very aware that there are foundational risks to our way of life across the Gulf Coast if we don't start to address some of these challenges immediately.
Absolutely. And, certainly my grandchildren who are just starting to college and finishing high school, they'll be your age when we're starting to give up, as they've given up in South Florida. And we do just ultimately throw in the towel and say, I guess we're going to have to just give up on the Mississippi Delta. As tremendously important as it is, not just to the Louisiana economy and ecosystem, but to the Gulf of Mexico ecosystem.
Yeah.
Friends in biology, I ask them, I say, how much are you guys worried about the net impacts of climate change on the Gulf of Mexico ecosystem? Oh, people haven't even gotten there yet. Where, you don't have a lot of time. And so, but there are places that are studying it. I think the UT lab in Port Aransas is, one group that's really doing some exciting work. But we have to accept the science.
Yeah, that's a pretty perfect place to end here. This has been a heavy conversation, but it's been a delight getting to chat through it with you and to think through some of these ideas. John Anderson is the author of Gulf Coast Demise, Climate Change, Conservation, and Saving the American Sea. John, it has been a delight getting to chat with you.
Same here. Thank you, Wes.
That's our show for this week. Gulf Streams is a co-production of KPFT Houston and Rice's Center for Environmental Studies and the Rice Sustainability Institute's Eco Studio. Produced by Weston Twardowski. Original music by Carter Dean. Research support provided by Sarah Tabrez and Antura Varma. Stay tuned for No Expectations with Marcus French here on KPFT Houston 90.1 FM, Galveston 89.5 FM, and Huntsville 89.7 FM.